Today's topic is about functional FMEAs. We're going to talk about when to perform a functional FMEA, what is the goal of a functional FMEA, and then we're going to look at a very simple example of how an FMEA can be performed, a functional FMEA. This is a way in which it can be performed. It doesn't have to be the only way in which it has to be performed. We've spoken a lot about hierarchical FMEAs, where we want to do FMEAs at different levels. For the functional FMEA, the right time to do a functional FMEA is when a functional concept and a functional safety concept is available. And at a functional safety concept or a functional concept, we're defining functionally what the vehicle has to do or a vehicle functionality has to do. And at the safety concept level, we are defining from a safety standpoint what is the safety function that needs to be implemented. So once this is implemented, we can then go ahead and do a functional FMEA. One of the main goals of the functional FMEA is it can be done to ensure that the functional safety concept is correct and complete. So normally in the functional safety concept, one identifies architecture and requirements that need to be implemented to mitigate safety goals. The functional FMEA is a perfect methodology to ensure that all safety goals are covered, all failure modes are covered, and there's enough mitigation mechanisms to prevent safety goal violations. Here's an example using cruise control. Here what I'm showing is a very high level functional architecture for cruise control. Driver request cruise control, driver requests what the target speed is. The driver request is then converted into a torque or an acceleration request. And this torque and acceleration request is then converted in an actual torque or acceleration. Notice that at this point there is no component. These are all functions. So this is the right abstraction level to do a functional FMEA. Here is an example of a functional FMEA for cruise control. The functional FMEA consists of the following columns: components or functions, failure modes, effects, the severity and its rationale, causes, and to keep it very simple, we just have a safety measure or safety mechanism. One can choose to implement an RPN and an action priority. It makes it a little more complicated. To keep it very simple, we can just have the structure. And in the end, there is a status and there's a recommended action. So let's look at one example. There's a function, the driver requests cruise control. And the failure mode is no driver request cruise control, which means the driver requests cruise control, but it just doesn't go through. Which means there would be a loss of vehicle acceleration. We can give this a severity of 5 because this is still a loss of secondary function and not a loss of the primary function. The driver can still press the accelerator pedal and take over. One of the causes for this would be an error in the HMI which the driver is using to activate cruise control. It could be a button, it could be a voice command, it could be something on the HMI screen. It doesn't matter, but there is an error in the HMI. A safety measure here could be that the driver is informed about the loss of functionality and that the driver should take over. As far as recommendations go, it is recommended that the system performs diagnostics on cruise control on the HMI, and this does not have to be done with A's and C just because the severity is low, it's not a safety critical issue, it can be still done with QA. And eventually, those diagnostics have to be linked to QA requirements. Here's another example for a safety critical issue. Unintended driver requests unintended driver cruise control request. The effect of this is unintended vehicle acceleration. So the vehicle starts accelerating by itself. This is a safety critical issue because it's going to collide with any traffic participant who's in front of the vehicle. Again, an error could be caused due to an error in the HMI. The safety measure here is that the cruise control can be limited to a safe value, the acceleration of the top request, which means it gives the driver enough time to notice that the vehicle is accelerating and then press the brake pedal to stop. This is eventually linked to an easel C requirement. Now notice what is happening here is that every time you build safety mechanisms and safety measures, we are linking it to requirements. If there are failure modes for which there are no requirements, then new requirements should be added. So this is becoming now a powerful tool to ensure, is your requirement set in the functional safety concept complete or not? The functional FMEA can be used as a way to ensure that the requirement set is correct and complete. And this is a very, very powerful argument that can go into uh, the verification report of the functional safety